This is video number 13, and it is going to cover homework parts 10 and 11, which you can find on pages 16 and 20. I'm going to label the following as synthesis, decomposition, single replacement, double replacement, or combustion. So here you have a single element plus a single element, and they combine to form just one product. So this is going to be a synthesis reaction. Remember, synthesis is also known as combination. So if two single elements combine, then that is a synthesis reaction. Number two, you have one compound and it separates into two or more substances. So anytime you start with just one thing, it's going to be a decomposition. Number three, we have a compound plus a single element, and you'll notice that the single element swaps places with the bromine. Chlorine and bromine are both halogens, and we get a new compound and a different single element. So this is going to be a single replacement because these replace each other in the reaction. Here you have a hydrocarbon plus oxygen yields CO2 and H2O. That is a combustion reaction. We have lead oxide, and it's only one reactant and it's breaking apart, so that's going to be a decomposition. Here we have a compound plus another compound, and notice we get first and last here, and then third and second. Hydrogen and hydroxide make water. This is a double replacement reaction. Here we have iron oxide and hydrogen. Notice that the hydrogen and the oxygen switch places. The hydrogen and the iron switch places. So you get the iron all by itself, and then the hydrogen gets with the oxygen to make water. This is a single replacement reaction. And finally, we have two single elements, and they combine to form one compound, and this is going to be a synthesis reaction. Part 11, and we're going to work through these problems, predicting their products and then balancing the equation afterwards. So number one, they had sodium and sulfur, and because it's two single elements, the only thing they can do is combine with each other, and so this is a synthesis reaction. So we're going to combine them, and you get sodium and sulfide, and the reason that we have the little 2 here is because we have to balance the charges. Sodium is a +1, sulfide is a -2. Crisscross, that puts a 2 next to sodium and a 1 next to sulfide, and so that's why this is the formula of our product. Neither one of these are a diatomic, so they do not get a 2 next to them, and then we balance the coefficients. You're going to need a 2 here to have 2 sodium to equal that 2 sodiums, and you have 1 sulfur, and so this is balanced as a 2, 1, and 1. So in number 2, you have a single element plus another single element, so this is going to be a synthesis reaction. Translate hydrogen gives me H plus bromine Br yields. These are two single elements, and so I want to combine them, and so over here I'll have HBr. Next, if it's a single element, the question is it a diatomic? Hydrogen is a diatomic and bromine is a diatomic. And then on the right side of the equation, we have to balance charges. Hydrogen's a +1 and bromine's a -1. Those cancel, and so now those charges are balanced. Finally, I'm going to balance the coefficients, and I have 2 hydrogens on the left, 1 hydrogen on the right, so I need a 2 here. And now that gives me 2 bromines on the left, and remember that this counts toward both of these, so now I have 2 bromines on the right as well, so this is balanced 1, 1, 2. So let's translate this one first. Nickel 3 sulfide, that's a compound. Nickel is Ni, sulfide is S. Nickel Roman numeral 3 has a +3 charge, and sulfide is a -2 charge. When I crisscross, this means I need a 2 there, and that means I need a 3 there. And then I'll draw my arrow. So because we have only one compound to start and nothing else, this is a decomposition. And so in a decomposition, the only thing you can do is break these two elements apart from one another. So it's going to be nickel plus sulfur. Neither one of these are a diatomic, so they do not get little 2 subscripts. Next, I'm going to balance my coefficients. We have 2 nickels on the left, 1 nickel on the right, so I'm going to need a 2 here, 3 sulfur on the left, 1 sulfur on the right, so I'm going to need a 3 there. And now this is balanced, so I'll go ahead and put a 1 here. Barium carbonate, if I were to translate it, I'd have +2 -2 on my barium and my carbonate, and +2 and -2 cancel. Because you have only one thing given, it's going to be a decomposition. Technically, this is as far as you could go. This would be a problem that you would omit because we do not know the rules for decomposing a carbonate compound. Though technically, if someone else is watching, it's barium oxide and CO2 would end up being your products, and then this is already balanced with a 1:1:1 ratio. But we'll move on to number 5 now. So let's translate. Zinc is Zn plus lead 2, so we have lead, it has a +2 charge, and nitrate is NO3 and it has a -1 charge. I'm going to need to balance my charges by crisscrossing, so this will get a 1, this will get a 2, and then zinc is not a diatomic, so it does not get a subscript of 2. Single element and a compound, this is going to be a single replacement reaction, which means you have to use an activity series in order to determine will this reaction actually happen. So an activity series, this, and we can see that the zinc is here and the lead is here. So because zinc is higher up on the list, it's going to get a smiley face, the lead gets the frown, and the nitrate is going to get the star. Remember, the smiley face, the star wants to be with the smiley face. So that means that the lead and the zinc are going to switch places. So I'm going to put the PB here instead, plus, and then I'm going to move the zinc here to be with the nitrate. On the right side of the equation, is that a diatomic? No, it's not, so I don't need a little 2. But I do need to balance these charges, +2 -1, crisscross. That's going to give me 1 zinc and 2 nitrates. And now that my charges are balanced, I can balance the coefficients. And so I'll draw my blanks. We have 1 zinc, 1 zinc, 1 lead, 1 lead, 2 nitrates, 2 nitrates. So this is an already balanced equation. All of the coefficients are 1. 6, we have aluminum plus magnesium chloride, magnesium and chloride. Aluminum is not a diatomic. Magnesium is +2, chloride is -1. Crisscross those, so we need a subscript of 2 here, and then yields. What kind of reaction is this? Single element plus compound is going to make this a single replacement, which means we have to use the activity series to determine is this reaction going to happen. So in my activity series, I need aluminum versus magnesium, and they are here and here. So magnesium gets the smile and aluminum gets the frown. Chloride is the star. Chloride wants to be with the magnesium, so this is no reaction. 7, fluorine is going to be F plus silver chloride. Silver chloride. Fluorine, is it a diatomic? Yes, it is. So it needs a subscript of 2. And then I got to balance the charges on silver chloride. +1, -1 will cancel. And so these are my reactants. This, again, is a single replacement reaction, which means I need to use the activity series. But this time, I am focusing on the halogens. So I'm going to look at the periodic table and look at the halogen family. And fluorine is higher, so it gets the smiley face. Chlorine is lower, so it gets the frowny face. And then silver's the star. So silver wants to be with the smiley face. That means the chlorine and the fluorine are going to switch with each other. So instead of the fluorine being there, it's now going to be the chlorine plus, and then it's going to be Ag, and instead of chlorine, replace it with the fluorine, and it becomes fluoride. Is that a diatomic? Yes, it is. So it gets a little 2. And then I'm going to balance these charges. +1, -1 actually cancel. And so now I have my charges balanced, so I can balance the coefficients. we have 2 fluorine on the left, 1 on the right, so I need a 2 here. We have 1 silver on the left. Now we have 2 silvers on the right, so I'm going to put a 2 here. Remember, this 2 counts toward both silver and fluoride. And then this 2 over here counts to silver and the chloride. We have 2 chlorines, 2 chlorines, so now this is balanced 1, 2, 1, 2. Number 8, we have bromine plus sodium chloride. Bromine is a diatomic, so we need a little 2 here. And then for sodium chloride, we have to balance charges. +1, -1 are going to cancel, and I'll draw my arrow. So what kind of reaction is this? Single element plus a compound is going to make this a single replacement, which means you have to use an activity series to determine will the reaction happen. Since this is a halogen, we're going to look at the halogens on the periodic table, and we're going to put our smiley face over the chloride because it's higher than bromine. So here's your smile, there's your star, and bromine is the frown. Star wants to be with the smile, so this is going to be no reaction. 9. Sulfuric acid is H2SO4 plus calcium nitrate is going to be CaNO3. So the sulfuric acid, you would just be told what that is. But for calcium nitrate, we have to balance the charges, and it's +2, -1. Crisscross puts a 1 here and then a 2 here, and that would translate our reactants. So what kind of reaction is this? You have 2 compounds, so this is going to be a double replacement reaction. And so afterwards, we're going to see, did we have a precipitate form? So when you do a double replacement reaction, we're going to react first and last. So it's the hydrogen and the nitrate get together. And I am not carrying this 2 over to that side. I'm not carrying that 2 over to the other side. But this 3 is part of nitrate, and so it does come over to the right-hand side. Plus, and then we're going to have third, which is calcium, hook up with the second thing, which is sulfate. So it's going to be calcium and SO4 for sulfate. I do carry that 4 over because it's part of sulfate. So now that I've predicted my products, I need to make sure that my charges are balanced. The hydrogen is a +1, the nitrate is a -1, those cancel. The calcium is a +2, the sulfate's a -2, so those cancel. So my charges are all balanced. So now we can balance the coefficients. On the left side, I have 2 hydrogens, and on the right side, I only have 1 hydrogen. So I'm going to put a 2 here. On the left side, I have 1 sulfate, and on the right side, I have 1 sulfate. On the left, we have 1 calcium. On the right, 1 calcium. And then on the left, we have 2 nitrates here, and this gives me 2 nitrates on the right. And so everything is now balanced. 1, 1, 2, 1. Now we'll use the solubility rules. So we're going to look for NO3, which is here, and that is soluble with no exception. So this is not a precipitate. And then calcium sulfate. Sulfate is soluble, and calcium is not an exception. So this is also not a precipitate. So we had no precipitate form in this one. Nitric acid is something that you would be told is HNO3 plus barium hydroxide. Barium is Ba, hydroxide is OH. Barium is a +2, hydroxide is a -1. We crisscross, so we need 1 barium, and this means I need 2 hydroxides. And now I can draw my arrow. So because this is a compound plus another compound, this is a double replacement reaction. So I'm going to take first and last. That's going to be hydrogen and hydroxide. And then third, second. So third is barium and second is nitrate. And then over here, I need to balance the charges. Hydrogen is a +1, hydroxide is a -1, those cancel. Barium's a +2 and nitrate's a -1, so that's going to crisscross. 1 barium, and 2 nitrates. Now that I have my charges balanced, I can balance my coefficients. And we have 1 hydrogen on the left, 1 hydrogen on the right, 1 nitrate on the left, 2 nitrates on the right. So I'm going to have to fix that. And that has modified my hydrogen. I now have 2 hydrogens. So I'm going to fix that over here. 2 hydrogens. So we have 2 hydrogen, 2 hydrogen, 2 nitrate, 2 nitrate, 1 barium, 1 barium, and finally 2 hydroxides, and this is 2 hydroxides. So this is balanced 2, 1, 2, 1. Number 11 is we have C6H14 plus oxygen, which is a diatomic, so it's going to get a little 2. And this is a combustion reaction. And all combustion reactions have the exact same 2 products, CO2 and H2O. So now that I've predicted my products, I need to balance the equation. 6 carbon on the left, 6 carbon on the right, 14 hydrogen on the left, 7 times 2 will equal 14 hydrogens on the right-hand side. Now I'm going to use a different color to count all of my oxygens. So on the right side of the equation, and this is oxygen that we're focusing on right now, on the right side of the equation we have 6 times 2 is 12 plus 7 times 1 is 7 oxygens total, which is equal to 19 oxygens. Because this is an odd number of oxygens, there's something very special that we're going to do to balance this equation. This odd number means I'm going to put a 2 here in this blank. I'm going to put that odd number here in this blank. And then I have to double both of these coefficients. So 2 times 6 is going to be 12. And 2 times 7 is going to give me 14. And now that I've done that, we have 2, 19, 12, and 14. Notice that I have 2 times 6 is 12 carbons, 12 carbons. 2 times 14 is 28. 14 times 2 is 28 hydrogens. And then for my oxygens, I have 12 times 2 is 24 plus 14 is equal to 38 oxygens, and 19 times 2 is equal to 38 oxygens. So with these coefficients, everything is now balanced. Last example is C12H22O11 plus oxygen is O2 yields. This is a combustion reaction, which means that it's going to have the same 2 products all day long, and that's going to be CO2 and H2O. So now that I have predicted my products, I can balance my coefficients. This one's a little bit more challenging because we have this oxygen here as well as this one, but we'll just deal with it one thing at a time. So let's start with carbon. 12 carbons on the left, so I need 12 carbons on the right. 22 hydrogens on the left, so 11 times 2 equals 22 hydrogens on the right. And now let's add up these oxygens first, and I'm going to do it in pencil. 12 times 2 is 24 plus 11 times 1 is 11, and that's equal to 35 oxygens. Remember, this is all to balance the oxygens. On the left side, I need a total of 35 oxygens, and notice here so far I have 11. So 11 plus what is going to equal 35? 24, right? 11 plus 24 equals 35. So I need this one to be equal to 24, and I can do that easily by putting a 12 here because 12 times 2 is going to equal this 24. So I have 11 plus 24 equals 35, which is going to be equal to this 24 plus 11 equals 35. So this is balanced with a 1, 12, 12, 11 ratio.